So this video explains how to find out the centroid and then how to find out the moment of inertia of the composite section. So here we have considered a simple section, that is the T section. So as you can see over here, this is the width W1, this is the height H1, this is the width W2, and this is the height H2. So you can substitute these values over here, and if you want you can use this Excel sheet directly to find out the values of x bar, y bar, then ixx and iyy also. So we know that x bar is given by a1x1 plus a2x2 divided by a1 plus a2, and y bar is given by a1y1 plus a2y2 divided by a1 plus a2. So let us try to understand how to find out these values of x1, x2, y1 and y2 first. So x1 is nothing but, so we'll take the extreme left, this particular axis or a reference is extreme left of the figure. Right? From this, the centroid, the distance of the centroid of this individual figure. So this is the first rectangle as we have shown over here. This is the another rectangle. Then we can draw these diagonals wherever they intersect. This is the centroid of that particular section. Here also, if you draw these diagonals, you'll get the centroid of this particular rectangle. The distance of this centroid from this reference, so this value is x1. Similarly, from the reference, the distance of the centroid, this particular value is x2. So that is equal to W2 upon 2, and x1 is also equal to W2 upon 2. So we can say that x1 and x2 they are equal to larger width divided by 2 in this particular case. Similarly, for calculation of y1 and y2, we have taken this horizontal bottom line as a reference. So from this, the distance of the centroid of the first figure, composite section figure, that is first rectangle, is y1. So that is equal to h1 upon 2 because this distance is h1. Then the distance of this particular centroid of the second rectangle from the reference is y2. So it will be equal to nothing but h1 plus this particular value, that is half of this h2. So y2 is equal to h1 plus h2 upon 2. So in this way, we can find out these particular values of x1, x2, y1 and then y2. Then areas can be calculated easily. So W1 into H1 will be the area of this rectangle. Similarly, W2 into H2 will be the area of this second rectangle. And once you know this particular value, you can easily find out the values of x bar and y bar. So suppose we have assumed the value of this W1 equal to 20 mm, this W2 is equal to 200 mm, then H1, this particular value is 180 mm and this H2 is 20 mm. And if you calculate the areas will be equal to W1 into H1. So now you can see it is A4 into C4 that is written. So A4 and this is C4. So this value is A4 into C4. That will give you the value of 3600. Similarly, this is nothing but area of the second rectangle, that is area of this particular rectangle, that is W2 into H2. So W2 is nothing but it is B4 and H2 is nothing but it is D4. So this value will be equal to B4 into D4. Similarly, X1 is equal to W2 upon 2. So that also we have written in the formula form, that is B4 upon 2. Okay, so this is B4 upon 2. Here also it is B4 upon 2. Then Y1 will be equal to H1 upon 2 because this is the value of y1, that is h1 upon 2, and h1 is nothing but it is represented by this cell C4. Okay? So it is C4 upon 2, and similarly y2 will be equal to this h1 plus h2 upon 2. So h1 is nothing but what, our this particular value, that is C4, and h2 upon 2 is D4 upon 2. So in this way we have calculated the values of x1, x2, y1, y2, and then these values we have substituted in this formula, that is a1 x1 plus a2 x2 divided by a1 plus a2. So you can see this is a1 x1 plus a2 x2 divided by a1 plus a2. Similarly over here we have used the formula of a1 y1 plus a2 y2 divided by a1 plus a2. So a1 and y1, so a1 is nothing but this particular value, that is B13. y1 is nothing but this value, that is D15. Then A2 is nothing but this value, that is B14. and D16, correct? That is the value of Y2, correct? Divided by A1 plus A2, that is these two, addition of these two cells, that is B13 and B14. So in this way we have calculated these values of X bar and Y bar. Now suppose we change this value. Suppose we take this as 10, this value as 100, then this as 90 suppose, and this as 10. Right? So we can easily get the values of X bar and Y bar using this particular Excel sheet. Now we can calculate the values of moment of inertia also using these particular values. So this part is same. So you are calculating x1, y1, then x2, y2 as usual. Okay. But now we have to calculate the value of Ixx. So to calculate Ixx, consider y bar and calculate the radius of gyration k3 and k4, taking the absolute values or mod values. So y bar minus y1 and y bar minus y2 will give you the values of k3 and k4. Similarly, Ix11 will be the moment of inertia of this particular rectangle, and that is 1 by 12 W1 H1 cube plus A1 K3 square according to the parallel axis theorem, and Ixx2 will be 1 by 12 W2 into H2 cube plus A2 K4 square, and the total moment of inertia will be equal to moment of inertia of this rectangle plus moment of inertia of this particular rectangle, that is Ixx1 plus Ixx2. Similarly, if you want to calculate Iyy, then consider X bar for the calculation of radius of gyration. So again, mod value of X bar minus X1 and X bar minus X2 will give you the values of K1 and K2 radius of gyration for the calculation of Iyy for this particular lamina. So Iyy1 will be equal to 1 by 12 H1 W1 cube, correct? So height first over here and then width cube plus A1 K1 square according to the parallel axis theorem, and again Iyy2, that is the moment of inertia of this particular rectangle about the y-axis using the what we can say parallel axis theorem. So it is 1 by 12 H2 W2 cube plus K2 K2 square, and summation of these two values will give you the value of Iyy. So Ixx and Iyy we have calculated over here. So first we have calculated K1, K2, K3, K4. So K1 is X bar minus X1. So X bar is this particular value. So you can see over here, it is X bar is nothing but this is E cell and this is E13 minus this is D13. So that value will give you the value of K1. Similarly, K2 will be equal to X bar minus X2, that is same cell E13 minus D14, that is this particular value. Similarly, we have calculated K3 and K4, that is Y bar minus Y1. Y bar is nothing but this value. So this is nothing but cell F13. So F13 minus this value, that is D15, Y bar minus Y1, and this is Y bar minus Y2. And substituting all these values over here, that is Ixx1, Ixx2 can be calculated, and then Ixx can be calculated. So here we have substituted this particular formula, that is this value Ixx1 is substituted over here plus Ixx2, so that you will get this particular value, and here also it is Iyy1, that is 1 by 12 this particular plus Iyy2, that is 1 by 12 H2W2 cube plus A2K2 square. So here also if you change this particular value, so it is suppose say 10, then this is 100, this is 90, and suppose this is 10, then you can get directly these particular values of Ixx and Iyy. So you can use this particular calculator of the Excel sheet prepared using Excel sheet for calculation of Ixx of the composite section like T section.